Welcome to the session on differentiation, parametric differentiation. The objectives for this session are to differentiate parametric functions. It is possible to find the gradient at a given point without converting to Cartesian form. We can do this by using the chain rule. So, if x and y are functions of a parameter t, then we have that dy dx equals dy dt over dx dt. This is of course obtained by rearranging the chain rule. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solution. In this example, we are required to find the gradient at the point P, where t equals 4 on the curve given parametrically by x equals t squared minus 2 and y equals 3t to the power 5. So let's solve this. If we differentiate x, we obtain dx dt equals 2t. And if we differentiate y with respect to t, we obtain dy dt equals 15t to the power 4. So applying this formula gives us 15t to the power 4 over 2t equals dy dx. And simplifying this expression, or cancelling out the t on the top and the bottom, we obtain 15 over 2 t cubed. So when t equals 4, we simply plug in t equal to 4 in the formula as shown. To give us 480. Therefore, the gradient at P is 480. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. We are required to find the equation of the normal at the point P, where t equals pi by 6 to the curve with parametric equations x equals 1 minus cos 2t and y equals sin 2t. So again, we're going to use the formula highlighted, and for this we need to find dx dt and dy dt. Differentiating x with respect to t gives us 2 sin 2t, and differentiating y with respect to t gives us 2 cos 2t. And so we have dy dx equals 2 cos 2t over 2 sin 2t. Which is equal to cot 2t. At the point t equal pi by 6, we obtain dy dx equals cot pi by 3, which is equal to 1 over root 3. And therefore the gradient of the normal at P is minus root 3. This is because the gradient of the line times the gradient of the normal to the line is equal to minus 1. Now at P, we have that x equals 1 minus cos 2 times pi by 6. which is equal to a half. and we have that y equals sine 2 times pi by 6. Which is equal to root 3 over 2. Therefore, the equation of the normal is the change in y, which is y minus root 3 over 2. And here, of course, xy is a general point on the line. And the y-coordinate is root 3 over 2. This is the specific point on the line that we have. Minus root 3 is the gradient, multiplied by the change in x. So again, xy is a general point on the line, and x equals a half is the x-coordinate of that specific point on the line. And so we have the equation of the normal. However, we can tidy this up, and we have that the equation of the line is y plus root 3x equals root 3. This brings us to the end of this session. If you have understood its contents, you should be able to differentiate parametric functions. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.